All right, so today we're officially going to get into chapter 8, okay, and all about polynomials, okay? So overall, we're going to go first through some definitions because, again, before we get into polynomials, we have to get in some terms before we get there. So our first definition is going to be a monomial, okay? A monomial is a number, so that first blank, we're going to put number. And I'm going to put like a comma, or if you want to put a slash, a variable, okay? Or the product of a number and one or more variables with whole number exponents. All this means is that this is one term, okay? So you're not going to see any plus or minus signs with a monomial. Mono means one. Okay, so if you see this, mono means one. A binomial is a polynomial with two terms, okay? Just know bi means two. So think of a bicycle that has two wheels. So a binomial is two terms. So you will see a plus or minus sign. A trinomial, again, see that root word tri. A trinomial is a polynomial with three terms. So again, tri means three. So again, think of a tricycle, okay, three wheels. Now, a polynomial, okay, is a difference, okay, or a sum of monomials, each called a term, okay? So just know poly, okay, that root word means four or more terms, okay? So again, a lot of plus or minus signs in a polynomial. Okay, if we're talking about the degree of a polynomial, the degree of the polynomial is the term, okay? Again, terms are separated by plus or minus signs of the highest exponent. Okay, so the degree, if I'm like, okay, what is the degree of this polynomial? You're going to look at the largest exponent, okay? So again, that little baby number that we just went over attached to the x, okay? Again, the highest exponent is the degree, okay? We have talked about standard form before. So every time we're talking about polynomials and answers, it should go in standard form, which means your first term should be our highest exponent. And then after that, it should go descending. So if my highest exponent is 5, and then it should go 4, 3, 2, 1, and the constant should always be that last term, okay? Talking about coefficients, okay? The coefficient is the number, okay, that is in front of that specific term with the variable. So it's just the number. You're never, ever going to include the letter or the variable. The leading coefficient, okay, is the coefficient of the first term. So again, it's the leading coefficient. So literally the first number you see, okay, when your polynomial is in standard form. And remember, a constant, okay, a constant is the term that hangs out at the very end in standard form, and it has no variable attached to it. So no letter is attached to it. It's just a number. Okay, so these are, again, the key information and definitions and vocabulary words that we will need to know to start this chapter. Okay, so I'm going to be starting to use these words a lot. Now, when we actually get into, okay, breaking up, okay, what do each of these, okay, mean and how can I identify? If I want to write this in standard form, I have to look at the highest exponent. Whatever has my highest exponent comes first. So if I look at my highest exponent, it's x to the third, and there's a plus sign, which just means this is a positive x to the third. So that's what I should see first, is x to the third. You can cross it out after you use it, because once you use it, you're not going to use it again. And the next highest exponent I see is this 2, but you see a negative sign in front, which just means it's not going to be a plus after the x to the third. It's going to be a minus 4x squared. And then remember, the constant or the number is always the last term you see. Now, if we look at coefficients, remember, coefficients are the numbers in front of every variable you see. So I for sure see -4, okay? Because that's in front of the x squared. So I know that -4 is a coefficient. But I also have another coefficient because, again, I saw x squared. But again, there's also a coefficient in front of the x to the third. If you don't see that specific number, just know a 1 is there. Okay? And then the leading coefficient is that number that's in front of the very front in standard form. Again, if we don't see a number, the leading coefficient is 1 if you don't see it. Otherwise, you would just write the number you do see. Okay, now if I want to classify specific types of polynomials, again, if I see a constant and a constant only, and I'm like, okay, well, what's my degree? Well, if you don't have a variable, your degree is 0. Okay, you can only have a degree if you have an exponent attached to a variable. And if I want to classify by this degree, well, again, this is just a number. So remember, this is called a constant. Okay, again, there's no letters, okay, no variables. Okay, so this, again, is the constant. If I want to classify by the number of terms, remember, if you don't see a plus or minus sign, you only see one thing and one thing only, then this is called a monomial. Okay, 1 is the loneliest number, if you know that song, okay? So if there's no plus or minus signs, just know that this is a monomial, 1 term. Okay, now once you start to see your variables, for sure there's going to be an exponent, no matter what. If you don't see the exponent, again, secretly there's an exponent there. It's 1. So my degree here, again, the highest degree is 1. If your highest degree is 1, this is called a linear, okay, exponent, which just means, again, a straight line like we've graphed. Y is equal to mx plus b. And again, in letter B, I see no plus or minus signs. So again, classified by the number of terms, this one is also a monomial. All right, in letter C, again, the exponent I see here, again, I do see an x. If I don't see the exponent, the degree is 1. Again, this is linear because that is the only exponent I see and the highest one at that. But now I do see a plus sign. So I have to look, okay, how many terms are there? How many, okay, terms are there in front and behind the plus sign? Well, I see 1 term in front, 1 term behind, which means that this is a binomial. In letter D, the highest exponent I see is 2 this time. So my highest exponent is 2. So you just write the highest one you see. If it's 2, to classify this by the degree, this is called a quad. Okay, and then radic. So a quadratic, okay, if your highest exponent is 2. Now again, let's see how many terms there are. So how many terms I see are 1, 2, 3. Okay, so again, this is 3 terms, so this is a trinomial. Okay, on the next one, again, the highest coefficient I see is 3. So again, my degree is 3. To classify this, if your highest degree is 3, this is called a cubic. Okay, a cubic. So 3 means cube, something cubed. Okay, I only see 2 terms here, so this is called a binomial. Binomial, because again, the number of terms is 1, 2. Okay, separated by plus and minus signs. In my next one, my highest exponent I see in this polynomial, okay, is 4. Okay, again, classify by the degree. So anytime you see that your highest exponent is 4, think of quarters, that there's 4 quarters in a dollar. So this is called a quartic. Again, how many terms do I see? 1, 2, 3, 4. I see 4 terms. And remember, 4 or more has the same, okay, name, and this is a polynomial. Again, a polynomial is 4 or more. All right, in this next one, my highest degree is 5. So again, the highest degree is 5, and this is called a quintic. So if you know someone who has, okay, 5 babies all born at the same time, those are called quintuplets. So this is just like that. This is a quintic. Again, how many terms do I see? 1, 2, 3. So this is a quintic trinomial. okay? After the number 5, you'll just hear the ith degree, okay? So the ith degree is your highest exponent is greater than or equal to 6. So after 5, there's no like cool name for to classify by the degree. It's just called the 6th degree, 7th degree, 20th degree. There's no really cool name after 5. Okay, now let's justify, okay, well, what if, okay, I don't see a polynomial? Because sometimes I'll throw an equation or something in standard form. I'm going to ask you, is this a polynomial or not? Some examples that are not polynomials is if your x is in the denominator. Cannot be a polynomial. So if I have 5 over x squared, okay, can't have that. Nope, nope, nope. That is not a polynomial. If I have x to the -1, can't have negative exponents, so not a polynomial. If I have the square root of x, okay, so underneath the square root, can't have that. So all of these are examples, okay, of not polynomials. So cannot have it in the denominator, no negative exponents, and nothing underneath this crazy, it's called a radical. So those are examples that cannot be polynomials. All right, so in this next example, okay, let's classify by the degree and by the number of terms. So if I look at letter A, my highest exponent that I see is 2. Okay, so again, 2, 2, 2, 2, 2. If I see the number 2, this should be a quadratic. So quadratic. And again, how many terms do I see? Separated by plus or minus signs? 1, 2, 3. So this is a quadratic trinomial. Okay, in the next one, again, my highest exponent is 3. So if my highest exponent is 3, this should be cubic. And then again, how many terms? 1, 2. So 2 terms means binomial. Okay, my highest exponent here, well, since I see a variable, I do have an exponent. If I don't see an exponent, remember it's the number 1. So this is a linear, and again, I only see one term because I don't see a plus or minus sign. Okay, so this one term and one term only is a monomial. And my last one, my highest exponent I see is 4, so think there's 4 quarters, so this is a quartic. Okay, and then again, 2 terms I see, so this is a binomial. Okay, so just know, okay, you're going to have to classify by the degree and number of terms. Okay, and that's how you do that part. When we get into the adding and subtracting of polynomials, when you add and subtract, it's just like combining like terms. Remember, with addition or subtraction, you do not touch the exponents. Okay, don't add the exponents. Nope, not with adding and subtracting. Okay, you only do that with, okay, multiplying or dividing with exponents. But when I add or subtract, you just combine the number in front. So because I'm adding 2, okay, things in parentheses, I really don't need them because I'm adding. Okay, so I can get rid of the parentheses and I'm going to rewrite it because that's a me thing, just without the parentheses. And with adding and subtracting, I just combine like terms. So whatever variable raised to that exponent. So I have 2x squared. Do I have anything else that's an x squared? Yes, I do. And again, if you don't see a number in front of your variable, you can always put the number 1. All right, my next like terms I see are something that has x. Oh, I have something else. And then my constants or my numbers, those are like terms. And again, in front of your variables, if you want to put a number, if you don't see the number, you can always put in a 1. Okay, so let's just combine like terms. So 2x squared plus 1x squared. That becomes 3x squared. Again, do not do anything with the exponents when you're adding or subtracting. Then let's take a look at my x's. 1x plus 1x, I get a positive 2x. And then a negative 5 plus 6. Because again, this was a minus, so makes it negative. I get a positive 1. And if you look at this, I put this in standard form automatically, which means my highest exponent should always come first, which is 2. And then it goes 1, and then my last term is a constant. So you should always put your final answers in standard form. But if we take a look at the next one, because we're subtracting, this changes things. I can't just write my 2 stuff in parentheses without them. Nope, nope, nope. What I have to do is anything that's behind a minus sign, I have to distribute a -1. Okay, then I can write it without the parentheses once I take a -1 and multiply it with anything that's inside the parentheses it's attached to. My first parentheses in front of my minus sign, I can write it as is because nothing's being multiplied in front. So I can write 3x squared minus 9x minus 8. But then once I distribute a -1, this becomes minus 2x squared plus 4x minus 11. So really when you distribute, it changes the sign that was originally inside the parentheses. And then after that, I just see plus and minus signs, so I combine like terms. I like to highlight my like terms just in case and the sign in front of it. So I have x squareds, my x's, and then my constants that again are just the numbers hanging all by itself. When I add and subtract, I don't touch the exponents. I only, touch the numbers in front and combine them. Again, we don't do anything with the exponents. They just come down as is. So I should get 1x squared or just x squared minus 5x minus 19. Because again, the sign in front. Number 6, okay, there's a lot going on in number 6, okay? So number 6, more is happening. If you look, I have a number in front of every single parentheses. So I'm going to have to distribute a lot here. So this 5x is going to be distributed with the parentheses it's touching. The -3x, because that's a -3, so makes it negative, is going to be distributed with every parentheses it's touching. And then this +2 is going to be multiplied with everything that the parentheses it's touching. So remember, when you do multiply, multiply the numbers. So 5 times x squared, again, just gets stuck next to each other as 5x squared. 5 plus 3x, again, multiplying them together gets plus 15x. -3x squared minus 12x plus 21. And then a minus 6x minus 8. And then again, after that, combine like terms. So I'll go ahead and highlight that just to make sure that we are on the right track of what like terms are. So anything that has x squared are like terms. Anything that just has an x are like terms. So we have more x's here. And then our constants, remember, are just our numbers that hang out all by themselves. Again, after I combine all my like terms, I get 2x squared minus 3x plus 13. All right, number 7. Oh boy. All right. So again, I see parentheses, so I have to see, okay, is there a number in front that I have to distribute before I combine? And there is. There's this -2 or -2 that's directly in front of the parentheses behind it. So I have to take that -2 and multiply with everything inside. The parentheses in front of the minus sign, I don't have to distribute anything, so I can just take out everything in here as is, just without the parentheses. And then I'm going to have to go distribute, so I get -12x to the third plus 8x squared minus 4x plus 2. And then after combining like terms, again, hopefully you can get the gist of what our like terms are without me highlighting them. Our final answer here in standard form, because my highest exponent always comes first, which is 3. And even if it's in the middle, it comes out as the first term, is -12x to the third plus 6x squared minus x plus 11. All right, last one. So if I want to write a polynomial that represents the perimeter of a figure, Okay, again, hopefully you're like, ooh, perimeter, perimeter, perimeter. What do I know about perimeter of any shape in the world? Well, again, perimeter means to just add up all the sides I see. Okay, I'm not multiplying, I'm not doing any of that. Okay, I'm adding up all the sides. I like to put them in parentheses just to keep them safe first. So my first term I see, or my first side that I see personally, is 3x minus 6. So I'm going to take 3x minus 6, and I'm going to add the other sides I see, which is 5x plus 4, and then add x minus 1. Again, I like to put them in parentheses just to keep them safe, just in case it asks me to do anything else. But because there's addition signs in between each of my parentheses, I can take out what's in parentheses as is, and I don't have to distribute anything. And then once I do that, again, just combine like terms, okay? So again, my like terms in this case are my x's. So I can go ahead and highlight those. So 3x plus x plus 5x. When I combine all of those, I get 9x. And then my other like terms are my constant. So negative 6 minus 1 plus 4. So when I do that, again, negative 6 minus 1 is negative 7. Negative 7 plus 4 is negative 3. Okay, and again, you can just use your calculator for the constants or any numbers that you have. Just put them in your calculator just to make sure, but put them in correctly with the negatives. Okay, so this was just day 1 of our chapter 8 notes of being able to classify, okay, by degree, okay, and by the terms, okay, and then adding, subtracting, and distributing, then combining like terms, okay? So you will have a Delta math assignment that is due by the end of class, before you leave, okay, to go home or to go to your next block. Remember, it's not homework because you have additional homework that I will post the last 5 minutes. So make sure you get your Delta Math homework or classwork done before you leave, and I will post your homework the last 5 minutes of class only. So you should be working hard this entire time when I'm not there. Otherwise, I will see you all on Friday. Have a wonderful day.